Hello everyone, welcome back to the channel. Now in this video we are going to continue the implementation of our AVL tree. Okay, so as you have seen in last video we calculated balance factor and we were able to understand if you are supposed to do the left rotation on what node and right rotation on what node. But if you remember our first lecture on AVL tree, right, we discussed about there are four types of rotation total, right, which is left rotation, right rotation, right, and left right rotation and right left rotation. So from this code we understood if your root is left heavy, we are supposed to do the right rotation on the root value. If your node is right heavy, we are supposed to do the left rotation on the root value. But in that case, we have to check one more thing. When you're trying to check if your tree is left heavy or right heavy, right, you're supposed to check if their left child or right child is in a position where it can be rotated. Okay, so if the unbalanced is in the different node, okay, in that case you're supposed to perform the rotation properly. Let's talk about our tree that we have right now. Let's say this is 10, okay, and this is 20 and this is 30, right? So this is a right heavy tree. In this case we are supposed to perform a left rotation on 10, right? So this is the root. In this case we know this is a clear cut because the imbalance is in right side. Okay, so in that case we are going to perform a left rotation. So the 20 will become root, and 10 will become the left node, 30 will become the right node. So that's how we know what kind of rotation we are going to perform. But what about this scenario when you have 30 here, right, and 20 here as a left node of a 30? So what you're supposed to do in this scenario? So as we can see, the imbalanced is in right left node. Okay, right side left node. It was RL rotation. You already performed right rotation, but there is still left rotation pending. So left rotation you are going to perform on this 10. Okay, so this will remain 20, but this 10 will come here, right? Now this will be your final tree. Now I have to explain to you about two different rotation. When the imbalance was in right side, that is RR. Okay, in that case which rotation you perform? Left rotation. Okay, and when the imbalanced was in right side left node, in that case you perform first right rotation and then left rotation. So that's how you got this balanced tree in the end. So same logic we are going to use to check if our tree needs that extra rotation or not. Now how you can do that? Now let's talk about our first case when we had 10, 20, 30, right? So in that case 10 was right heavy, right, which was this case. So this was supposed to perform left rotation, right? So here let's keep this in braces, this as well. So if this is a right heavy, so on this one we are supposed to perform left rotation. Okay, so let's write that left rotate this value, root value. Okay, but before that we are supposed to check if balance factor of root dot right child is greater than 0. Okay, now in this case you are supposed to perform a different rotation, which is you're supposed to right rotate this same node. So let's write that as out, right rotate which value? Root dot right child dot value. Okay. Okay, so we have written there itself. It's supposed to keep this 0 out if it is greater than 0. Now this is a correct balance factor condition. If the balance factor of root dot right child is greater than 0, then perform the right rotation on the same node value. Okay, and then perform left rotation on the root value. Now the same thing is supposed to happen in a reverse manner when your tree is left heavy. Okay, don't worry, at the first attempt it might be, looks a little tricky. If balance factor of root dot left child is less than 0, in that case, okay, again I have written inside. Okay, let me change it as less than 0. So you're supposed to perform the left rotation, left rotate. What you're supposed to left rotate? Root dot left child dot value. Perfect. Let me fix this as well. Right rotate root dot value, which is perfect, and this as well. Okay, so we have written our logic. So as we have written earlier, if our root is left heavy, perform the right rotation, but before that check if the balance factor of root of left child is less than 0. In that case, first perform the left rotation on that particular node. Similar way, if the root is right heavy, you have to perform the left rotation anyways on that particular root value, but before that check the balance factor of the right child. If that is greater than 0, first perform the right rotation on that particular node, and then as usual perform the left rotation on the root. We are going to verify both of the scenario. Okay, that is 10 20 30 and 10 30 20 as well. So as usual, we know this is a right heavy tree, so we are supposed to get left rotate 10. Let me run this and see if we are getting that or not. We are getting correct, left rotate 10. Now our logic is working perfectly fine for this particular rotation, right? Now let's check the other scenario, which is 10 30, and then we are entering 20. Now this is a scenario where now this is a scenario where you have to perform left rotation anyways on 10, but before that you'll have to perform right rotation on 30 as well. So let's see if we are getting both of these or not. If you are getting both of these, then our logic is working perfectly fine. Okay, as usual we are getting, so we are getting, first is supposed to right rotate on 30, so 30 comes down, 20 comes up, and then you're supposed to perform left rotation on 10. So now our code is in a stage where it has calculated the height at the time of insertion itself, and there itself it is able to check if your root node, right, whatever node that is there right at the time of insertion, is left heavy or right heavy with the help of balance factor obviously, and we are able to check what sort of rotations we need to perform to make this tree balanced. Okay, now we are able to check if our tree is imbalanced or not, and we know what sort of rotations we have to perform. So we are clear till this point. Okay, now in the next video we are actually going to implement that rotation method, and we are going to see our method as balanced finally. Okay, that's all I wanted to explain as part of this video. See you in the next one.